So we're going to finish up 7-1. We did just a little bit of 7-1 yesterday. We just did rectangles, so today we're going to do parallelograms and triangles. So let's just, they give an example with a rectangle. I guess we'll do it. It's hardly worth doing, but it's pretty simple. Do you remember what the formula is for the area of a rectangle?
A1 plus A2.
A1 plus A2? What?
So, come on.
A equals 1.
Oh,
That's right. You could call it length times width, or you could call it base times height. Now this book is using base times height. If you went to another book, they possibly could say length times width, but this book is saying base times height, which is perfectly fine. I have no issue with that. So we're going to use base times height. Is that all right? But again, you might have learned in the past length times width. It's the same thing, same exact thing. Except when you say base times height, height is something specific. Remember we talked about that yesterday? The height, if this is the height and this is the base, what has to be true? There's got to be something that's true about the height and the base. You remember? Parallel? Perpendicular, that's it, okay? They got to be perpendicular to each other. Everybody hear that? So the height, when we define height, we define it to be the perpendicular distance. Remember we talked about the airplane and the ground? Okay, the height would be what? It's the perpendicular distance from the plane to the ground. So height specifically means perpendicular to the base. Everybody got that? That's super important, especially for what we're going to do on parallelograms. All right? So rectangle's pretty easy. So the example is, let's get rid of that. And let's put the rectangle back in here. The example, they say this is 3 inches and this is 5 inches. And they want you to find the area of this rectangle. Pretty simple. Would you agree?
Yeah.
So let's do it. So, and I'm going to show a little bit of steps here because of something in particular I want to tell you. Okay, so it's 3 times 5, or it's not just 3, it's 3 what? Inches. Because when we do area, we measure it in a certain units, okay? We could measure it in centimeters, in inches, in feet, in miles, in yards, in meters, or whatever, okay? So it's 3 inches times, I'll just use parentheses, times 5 inches. Agreed?
Yeah.
All right, so do the math. It's pretty easy. 3 times 5, 15. Now, do we just say A equals 15 and circle it?
15 inches.
Right? Is it inches?
Square.
It's inches squared. Why is it inches squared? Because inches times inches
Square.
Where?
is inches squared. I'm sure you're just joking about saying cubed. All right, so 15 inches squared. Everybody got it? I made a big deal yesterday about it, and I said if you don't put the inches squared on here, guess what I'm going to do to this problem? If this is number 1, well, I'm just going to mark it wrong. Okay? Everybody see that? So that's the second time I've warned you about it. So don't come to me after a quiz like, yo, Mr. Hamrick, why do you take off points just because I didn't put inches squared? Well, I'll refer you back to yesterday's video and today's, and I'm going to tell you that I told you that I will take off if you don't put it. And if it's not correct, if you just put 15 inches, that's not correct. Everybody got it? Okay. So make sure that you put inches squared. All right, enough of that. Let's move on to parallelograms. So let me, I don't think I have a pre-made parallelogram. I should have put that over there on the side. But I can do this, though, I think. Is it transform? Shear, that's what I want. And I don't know, let's go 20 degrees. There we go. Now we got a parallelogram. What is that? Yeah, I probably did. Well, I actually learned this the other day. Just had to remember how to do it. All right, so let's take a look at this. This is a parallelogram, and you really don't know it's parallelogram just yet until I tell you a couple things, right? If I tell you that this is true, now what can you say about it? Now you can be confident that this is a what? Parallelogram. Okay, good enough. All right, but sometimes they'll just tell you. They may not even mark it like this. They might just tell you at the beginning, parallelogram, ABCD, you know, or find the area of parallelogram. So sometimes they'll just tell you in the problem that this is a parallelogram. So you know that these are going to be parallel to each other. Everybody understand that? Okay, so you don't always have to see that these are parallel, if they just tell you that it's a parallelogram, that should be good to go. All right, so on a parallelogram, it doesn't matter if you tilt it up. But the way it's tilted right now, we'll call this one the base right there. So that would be the base. Everybody see that? Yes? All right, so that's the base. Now, what I want to see is what is the height? Is this right here? I'll put height, and I'm going to put a question mark. Now, me asking the question like this, what do you think? It's probably what? Not the height, okay? Just, what do you think?
It's gonna, you gotta do a dotted line down from like one of the corners straight down.
Okay. Don't say straight down. What word did we use?
Perpendicular.
Perpendicular. Let's say perpendicular, okay? I know what you mean, and you are right when you say straight down, but I think it's better to say perpendicular. Instead of a dotted line, I'm just going to use a different color line. Is that all right? So you could go from anywhere. You don't have to go from a corner, okay, but you can. You can go from anywhere up here, okay, and then draw it perpendicular to the base. You with me? But a lot of times they will start at one of these vertices, and they'll make it perpendicular right there. So if I know that that's a, whoops. Oh, I got to click off of that before I start writing. Okay. If I know that that's perpendicular right there, that yellow line right there is the what?
Height.
Is the height. Everybody with me? Okay. So I'm just going to give you the formula right now. So here's the formula for the area of a parallelogram. I'll just put P for parallelogram. Is that all right? So the area of a parallelogram is exactly the same as the area of a rectangle. Because the area of a rectangle is a what? Parallelogram. Agreed? All right. So what is it? It's the base times the height. Now, again, you've got to understand the definition of height is what? It's a perpendicular distance. Okay, so you got to use a perpendicular distance. You could also do this. Let's go back. That's not the only place that the height could be. Sometimes they'll do this. You could actually find the height outside of the parallelogram. So a lot of times they'll do this. Let me start right here. Let's extend that side out like that. Is that all right? That's still a parallelogram. I just took one of the sides and extended it. Let's change it back to yellow. So the height could be anywhere on this line perpendicular to the base. Well, this technically isn't really part of this, but it's extended, isn't it? All right, it's extended out like this. So if you wanted, and there are times you're going to do this, and you're going to see in the next one we do triangle, you'll see where it really comes into play. All right, so this right there, that could also be the what? That could also be the height, even though it's outside the parallelogram, okay? Because it starts at one side of the parallelogram, and it goes what? Perpendicular to the opposite side. Everybody see that? I could have done it right here. I could have started right here and gone perpendicular to there. All right? These are all the heights. Yeah, you still get the same answer, okay? Now, when we talk about the base, we're talking specifically about just one of this side of the parallelogram. Everybody see this? Right there and right there. You understand what that means? Okay, that means it goes from here to here. If I extend this out, the base doesn't keep on going out there. It's just the part of the parallelogram. So this is your base, this is your height, multiply them together, and that's easy. You can find the area of a parallelogram. Now, let me draw another parallelogram as an example, and then we'll do triangle, and then we'll be done. Okay?
Triangle, you do like something and something. One time.
It is, and I'm going to show you why that's true. Let's do, yeah, this is stuff. You probably didn't do this with parallelogram back in 7th grade, but you probably did it with rectangle, square, and triangle. Okay? So, again, let me, oops, I don't want that. I want that one. What did I do? Transform, shear. Let's go like negative. Where's my negative? Right there. Let's go negative, I don't know, 40. Ooh, that looks pretty close to what the book has. It's about like that. Okay, good enough. So they tell you that this side right here, they label all the corners and stuff, all the vertices. I'm not going to do that. We're just going to, well, yeah, let's do it. Might as well. A, B, C, D. And here's what the problem says. This is example 2. Okay, they say find the area of, what's that little symbol? Parallelogram of ABCD. So do you have to see that there's parallel sides on here and all that? No, they don't have to show that. They told you it's a parallelogram. So everything is true about a parallelogram is true about this thing because it's a parallelogram. All right. What if they just gave you those two numbers right there?
Opposite sides are equal.
Okay, opposite sides are equal. That's true. But is that going to help us? Is that going to help us finding the area of this thing?
No, all of this one doesn't.
Do you?
Yeah.
You sure?
Oh,
No.
7th grade.
You would have been wrong in 7th grade, and you're wrong in 9th grade. Okay. We just talked about it, right?
Oh, wait, I'm thinking
If this
of
is the base, is that the height?
No.
If this is the base, is that the height? No. It's got. Where's the height got to be? Let's use 25 as our base, okay? Because that's what they give you right here. Now they don't give you enough information right now. If this is all they gave you, you wouldn't be able to find the area of it, okay?
I was thinking of 25.
So let's do this. It's base times height, remember? Okay, and there's something specific about the height. What's specific about the height? It's not just the two sides of it, it's perpendicular to the base. So we have to know what's perpendicular to the base. And they give it to you. I haven't given you everything that they've given you, okay? But I just wanted you to see that you can't just take those two, multiply them together, and get the area of it. You got to find the height. What's the height? It would be about right there. Does that look perpendicular? That looks pretty close, right? See what I did? I started at one corner, right? And I went perpendicular to the other side. So guess what this yellow line is?
The height.
It's the height. It's the height, okay? And they do tell you it's 10, all right? So they tell you it's 10. And by the way, these are all in inches. Because when you do area, you're measuring something, right? So you got to use some kind of units of measurement to measure something, agreed? All right. So now let's take a look. Which one is your base now and which one is your height? Well, what is this perpendicular to? It's perpendicular to this one right here, agreed? So what is this length right here? That's 25. You see it? So this is your base. This is your what? Your height. Everybody got it? Now, we didn't come up with 10. They told us it was 10, all right? But if they give you all these numbers right here, it's not 25 times 13. The 13 really doesn't have anything to do with finding the area of this, okay? Everybody good with that?
Yeah.
All right. So the math is easy. So area is base times height. So what is the base? 25. Let's make sure we put the inches in there. Times what? 10 what? Inches. And then that's going to be what? 250. And then inches times inches is inches squared. Don't just put inches for your answer. Area is always squared. Why is it squared? Because what do we do when you find the area? You're trying to find out how many what are inside there. No. How many squares, right? How many squares are inside of that thing? Does that make sense? When we find area, we always try to find out how many squares can you fit inside of that figure, in this case a parallelogram. Well, you can fit how many? 250 of them. Everybody got it? Yes, sir.
Will we have to figure, will we ever have to figure out, how we figure out the percentage will we ever have to change the base?
Not in this particular situation. We are going to do something. Remember we did Pythagorean theorem earlier? But they never officially taught you Pythagorean theorem. Guess what they're doing in this chapter? They're going to teach you officially Pythagorean theorem. So there will be situations, okay? It is. There will be, not this section, but I don't know what section it is. But I was flipping through the book the other day, and I saw, oh, we're doing Pythagorean theorem in this chapter. Okay, so it's not just all area. So they actually switch it up. It's kind of weird. Usually, when the first lesson is the area of something, everything else is going to be about area. But that's actually not true on this chapter. Again, this is my first year teaching out of this book, so it's all kind of new to me as far as how they order things, you know. But the other book I taught out of, if they said the first one was area, then it was everything was about like area and volume and stuff like that. Remember doing volume? Okay. I thought they were going to do volume in this chapter, but they're not. It'll probably be in another chapter. And we're doing circles in this chapter too, so it's kind of weird. It's not really weird because we're going to do the area of a circle, and we'll learn some other things about a circle. Okay, but it's a good question. Will you ever have to find this? Yeah, there will be situations, but we're going to wait until after the Pythagorean theorem, and then you might have to find this. Okay? 7.3 is Pythagorean theorem? Okay. So just a couple more. What's the next lesson? What's the title of that?
Circles.
Areas of other quadrilaterals.
Okay.
Oh, that.
All right. So let's do another one. Let's do... So what are the three things? It was rectangles. We just did parallelograms and triangles. So now let's do triangles. Let's change this back to white for my regular writing. All right. So let's do the area of a triangle. I could just sit here. And actually, Ben already told us what the area of a triangle is. But what I want you to do is I just want you to kind of see why it's that. All right. So if this is a rectangle, then this is the what? Base, and this is the height. And it actually doesn't matter which one you call it. If I wanted to call this the base, I could, and then this would have been the height right here. Everybody understand that? It doesn't always have to be the bottom one, because this thing could have been slanted, and twisted around and all that kind of stuff. But as long as they are what? Perpendicular, then one is the base and one is the height. All right? So what if we did this? Change colors here. What if I went from here to here? Good, it would be a hypotenuse. Thought I changed color.
Okay.
Hold up. Boom. There. Thought I changed colors, but there we go. All right, and you're right. It would be the hypotenuse because this would be a right angle if it was a rectangle, and this is opposite that right angle. This would be a right angle right here. This is opposite that right angle, so absolutely it is a hypotenuse. But what I'm looking at right now is, again, what are we going to find? The area of a what? Triangle. Do you see any triangles in this?
Yes.
Yeah. So what was the area of the whole rectangle? The whole rectangle, I'll put R for rectangle, was what? The base times the height. Would you agree?
Yep.
What we want to do, we want to come up with a little formula. I'll tell you, I'll write the whole thing out. Because eventually we're going to do the area of a trapezoid. Okay, so I don't want to put just T, so I'll put triangle. The area of a triangle is, now take a look. How much of this rectangle is each one of these triangles? It's half of it. Exactly right. Everybody see that? Okay, it's exactly half. This one and this one are exactly the same, right? And because if it's a rectangle, then this is B, then this is H, right? You've got this side equal to this side, right? These two bases are the same because it's a rectangle, right? The opposite sides are equal. So these are congruent triangles, agreed? If they're congruent triangles, it means each one of them are half of the whole entire rectangle. Make sense? So let's come up with a formula for our triangle. It's the base times the height, which is the whole rectangle, but what do we do to find just one of those triangles? We divide it by 2. We take half of it. Or you could write it, or you could say what? 1/2 the base times the height. Okay? A lot of times books write it like this, and that's perfectly fine. Got no issue with that. But when you actually start doing the math, I kind of prefer writing it like this. Okay? Everybody see that? I just think it makes it a little bit easier. Really doesn't make any difference. All right, let's do an example. Actually, let's do this. We've harped on this a lot today about the height. What must be true about the height and the base? They got to be perpendicular to each other. So let me draw a triangle. I'm going to try to draw it so it's an acute triangle. But sometimes it's weird. Sometimes it seems like no matter how I draw it, I always draw a right triangle. And yeah, let's just do it like that. Okay. Let's do it like this. Right there. That's good. Not being too picky. All right, here's a triangle. Would you agree? All right, let's say I call that the base. Everybody see that? Where is the height?
It could be both of the sides, right?
And it's not necessarily a bisector.
Could it be both of the sides?
Is it both of the sides?
No.
Remember, what has to be true?
Oh.
I gotta pound this into your head. What has to be true about the height and the base? They got to be perpendicular, correct? So, is this side right here perpendicular to the base? Is this side right here perpendicular to the base? No. Can either one of these sides be the height? No. So where do I go? I go from the top. Don't say straight down. Perpendicular to the base. Everybody see it? So this, if it's perpendicular, this pink one right here would be the height. Everybody see it? Most of the time, especially in the beginning, they'll probably give it to you. All right, and it might be a dotted line. I just made it a different color. They might put a dotted line or something. But this is the base. And where is the base? Is it just from here to here? No, it's the whole entire thing, right? From here all the way to here. That whole side right there is the base. Everybody with me? All right. What if we had, let's change back to white. What if we actually had a right triangle? Okay, and then right there. And I knew that was a right angle. Let's say that was the base right there. If that was the base, where's the height on this?
Left side.
It's that left side, isn't it? Okay, because it's what? It's perpendicular to the base. It's already perpendicular to it, okay? So this is the only situation where one of the sides is actually going to be the height. Everybody see that? Okay, what other kind of triangle could we draw?
Obtuse.
Obtuse. So let's draw an obtuse triangle, and let's check that out. Just lay it down anyway. All right, let's take a look at this. And what if I call, oops, what did I just do there? What if I call that the base? Where's the height? Well, it's from this vertex where? Is it down like this? Is it this side right here?
No, it can be like from the top
Yeah.
and then go straight down.
Okay, straight down. Okay, remember I said I don't want to say straight down. I want to say perpendicular. But what am I going to make it perpendicular to?
Base.
Where's the base, though? The base is way over here. How can I make this perpendicular to this?
The base can't extend out.
I can extend it out. Exactly right. Okay, so I could take that base. I could extend it out. Everybody see that? Now, does that make the base any longer? No, the base is still from here. Whoops. The base is still from here to here. Everybody see that? So even though I extended it out, it doesn't make the base any longer. I just extended the base just so I could give me a place to go down to. So now let's do this. Let's try to stay color coordinated a little bit. So I'm going to go from here. Where do I go? Perpendicular to that extended base. All right, and then that would be the height. Okay. So those are the tricky situations right here. Okay, make sure that you know, if you know the base, you should know which one is the height because it's always perpendicular to the base. Even if it can't reach the base itself, you extend the base out and then you can pull it straight down, okay, or perpendicular. Everybody with me? All right. So let's do an example and we will be finished. Let's turn this back to white. And so I'm going to have one side here. I'm going to have another side like right here. And then we'll connect them about like that. All right. So here's what the problem's going to say. It's going to say, well, this isn't just straight up find the area. All right, because that would be easy. If they give you the base and they give you the height, that'd be super easy, wouldn't it?
Yeah.
Just go base times height divided by 2. No big deal. We don't really need an example to do that. But this one, it's a little bit different. They're actually asking you to find the height, okay, of triangle, and they call it XYZ. XYZ, all right? So this is X, that's Y, and that's Z. So find the height if, and they tell you this. They tell you the area. So they're not asking you the area of this triangle. They're actually telling you the area. So they tell you it's 54. They put it in feet this time, and it's square feet. So what you want to do is find the height. They do tell you something else. They do tell you that that's 12. From here to here is 12. It's feet. Everything's in feet. Okay? So what do they want you to do? They want you to find the what?
Base.
Find the height. Got to find the height. All right. So where would the height be? If this is the base, then I'd start at x and I'd go what? Perpendicular. Very good. Perpendicular to the base. So this is what I'm trying to find. I don't know it. I'm trying to find it. So how in the world am I going to find it if I only know the base? Well, I know the area though, don't I? So look, area equals base times height. I know 2 out of the 3 things, don't I? So we will. But let's set up the formula first. So what is the formula? Area of a triangle. Area equals what? Base times height divided by 2. So now what we're going to do, we're going to plug in all the stuff that we know. So we know the area. What's the area? 54. I'm just going to put numbers in here, and I'm not going to put the units doing the math part. What is the base? It's 12. Times the height. Don't know the height, so I'm just going to put h for height. But then what do? We have to divide it by 2 because it's the formula. Exactly right. Okay. You could do this a couple different ways. You could just, I would divide this by 2, wouldn't you? So take this, divide it by 2. What's that going to give us? 6. Now what do we do with that 6? Divide both sides by 6. Let's just write it down just so you're not confused. Right? So we get this. And now we got to get rid of the 6. And what is 54 divided by 6?
9.
9. H equals 9. Do we just write 9 and circle it though? It's a unit. Do we put squared on this one? No, because area is squared. What's the height? It's just in feet. So the height would be just 9 what? 9 feet. Okay? You can just do it like that. Again, you must have the units in here. I'm going to be really picky on this. You guys are taking physical science now, right? Are you? Oh, you took it last year? Oh, wow. Oh, that's right. You're advanced, right? Did you do like physics stuff in there? Did you do like velocity and acceleration and stuff like that? Okay. Didn't you have to put units on your stuff there, right? Like meters per second squared and all that? Yeah. So that's the same here, right? You're measuring it in certain units. You can't just say 9. It's got to be 9 feet. Because what if it was 9 inches? Then you'd be wrong. This is not 9 inches, right? It's 9 feet. It's a big difference between 9 inches and 9 feet. Would you agree? Sure. So make sure that you put the correct units. This is not area, so we don't put squared. Okay? The base is always just in feet in this situation. The height would be in feet. And that's it. It's not so hard, is it? No. They're starting off pretty easy. So let's write down what your assignment is. I didn't assign anything yesterday, did I? So we'll sign it today. Are we still on track with our original lesson plan things? Anybody got it out?
No.
Are we a day behind? We are?
No.
I think we're right on time. Right?
Thursday, not bad.
Today's Thursday, right? So we're still on track, right? Then tomorrow I sign part B. Is that correct?
Yeah.
All right. So we'll split it up. And I'll probably give you a lot of class time tomorrow. I think. I don't have my. I guess I could look. Yeah. So I'm not teaching another lesson tomorrow. So we'll go over this one in class tomorrow, and then I'll give you time in class to work on the second part of it. The second part would be 24 to 31. Okay. It's on your lesson plan thing. You can look at it yourself. Everybody good?